So today we're going to talk about the binomial distribution. A classic example of a binomial distribution is flipping a coin 10 times and counting how many times you get a heads. So we'll talk about the four conditions here. Independent trials means that what I flip on one of the flips does not affect what I get on another flip. So if I get a heads on the first try, that doesn't affect the likelihood of getting a heads on the second try. 2, each trial is either a success or failure. Either we get a heads or we do not get a heads. Number 3, a constant probability of success. We have a 0.5 or 1/2 chance of getting a heads each time we flip a coin. And 4, we have n trials and are counting the number of successes. So if we have 10 trials, and we're going to try to count how many times we get a heads. So we're going to look at an example now, not a coin, but an example of a binomial distribution. This says, let's suppose a lumber grader has a 0.85 chance of grading the lumber correctly each time it grades. Suppose we want to grade 4 pieces of lumber. What is the probability that exactly 2 pieces of lumber are graded correctly? So if we think about this, we have, let's say we have check, check, x, x. Now what that represents is the grader got the first 2 pieces of lumber correctly and then the last 2 incorrectly. Okay, and we can come up with the probability that that happens. Because these are independent events, we can multiply the probability that each one occurs. So this has an 85% chance of occurring, times another 85%, times, this is actually 15%. If there's 85% chance that it gets it right, there's a 15 or a 0.15 chance that it gets it wrong. And this is also 0.15. So what we have is 0.85, 2 of those, 0.85 times 0.85, and then we have 0.15 to the second power. Okay, so 0.85 times 0.15 times 0.15. Now that's not the final answer to our problem, because that's just the probability of getting this exact sequence: success, success, failure, failure. Well, there's other ways to get 2 out of the 4 successes. So what we're going to do, we're going to list those 4. So, or list those possible ways. So this is, let me start this with a check. This can't be a check again. This is the exact same sequence. So this has to be an X here. So let me try that. This has got to be X. I also have check. I can have 2 X's here. And you don't have to do the same thought process I'm doing, as long as you make sure you're getting all the sequences. But what I've done is I've listed all the ones that had check first, and that's the only ways you can do it. So now the rest of them have to start with X. So maybe I have X, X, check, check. Start with X again. I can't have X in the second place, so it's got to be check. Let me go check X, and there's actually only one more way that it can happen, and that's check, or X, check, X, check. Okay, there's 6 ways that it can happen. So 6 ways that you can get 2 out of the 4 successes. So if we multiply that probability by 6, then we do get our probability. Because if you notice, each one of these sequences has 2 checks, which has a probability of 0.85, and 2 X's, failures, which has a probability of 0.15, the machine not grading it correctly. So each one of these sequences has the same probability, so we multiply it by the number of ways that it can happen, and that'll be our final answer. So we'll take a look at the calculator. Okay, we'll take a look at the calculator here. I'll leave my probability formula over here. So what we're doing first, turn it on, is we're going to do 4 choose 2. If you've ever heard that before, 4 choose 2 means how many ways can you choose 4 successes out of 2. So we go to 4, we go over to math, we go over to probability, go down to option 3, that's the symbol for choose, and we do 4 choose 2. We see how many ways. 4 choose 2 gives us 6, which is what we got. There's 6 ways that you can choose 2 successes out of 4. So let's go ahead and do we don't have to do this, write out the sequences every time. I wanted to get some concept about where this number comes from, but you don't have to write out those sequences every time. Okay, so I'll multiply that by 6 times 0.85 to the second times 0.15 to the second, and then we'll get our probability. That's the probability of getting exactly 2 of the 4 successes. Now, there's also actually a built-in option in the calculator that will do the entire thing in one sequence. So let's go to second variables, which is the distribution key. Same thing that we used when we did normal CDF. Now, at the very bottom of this, we have binomial PDF and CDF. So I'm going to go up because that'll get me to the very bottom. I'm going to go to option A, which is binomial PDF. Now, what binomial PDF does, I'll bring up a prompt here. It says, I have 4 trials. The probability of success on any trial is 0.85. And our X value is how many successes you're trying to find. We're trying to find what's the probability of getting exactly 2 successes. So if we paste that, hit enter. Notice we get the same thing that we did when we did by hand. So there's a built-in formula of getting a probability, a binomial probability. It's called binomial PDF. So this is the binomial formula, binomial distribution formula. N choose K tells you how many ways you can choose K successes out of N trials. The probability of success, which is our 0.85 here. How many successes we wanted, which was 2. 1 minus P is the probability of a failure. If there was an 85% chance of success, 15% chance of failure. And then N minus K is, if you get K successes, if you subtract that from how many trials you get, that's how many failures you had to have. In this case, they're the same amount, but that's N minus K is how many failures you have. So let's look at another example. Same setup here. It says, suppose we want to grade 4 pieces of lumber. What is the probability that exactly 3 pieces of lumber are graded correctly? So let's use our binomial probability. Use the calculator again. We want exactly 3 out of 4 successes. So let's just do it all in one motion again. That's second variables. Go to option A, which is binomial PDF. And it brings up this prompt. And you have how many trials, that didn't change. Our probability of success is still 0.85. What did change was our X value. We want the probability of getting exactly 3 successes. Okay? And that gives us that. So let's look at another example. This says, suppose we want to grade 5 pieces of lumber. What is the probability that exactly 4 pieces of lumber are graded correctly? So we're going to use a different number of trials here and number of successes. Go back up to binomial PDF. This time we have 5 trials, and we want to find the probability of getting 4 successes. So just so you see that one more time. That gives us that. Oh. So now now we have a different problem. It says, what is the probability that two or less, we're checking 4 pieces. It says, what is the probability that 2 or less pieces of lumber are graded correctly? 2 or less. So we have to think about what 2 or less means. And that means 2, 1, or 0. You can get 0 successes, which means the machine graded all of them incorrectly. You get 0 successes, you could get 1, or you could get 2 to satisfy this condition. So if you do binomial PDF, you can add up these 3 probabilities. So let's try this. So go back, we have 4 trials this time. This is getting 0 successes. Again, it's just doing that formula that we just learned, the binomial distribution formula. Paste that. I'll do plus. I'll go in and do 1. This is the probability of getting exactly 1 success. And I'll also add the probability of getting 2 successes. This is 0, 1, or 2. So that's what satisfies this condition, 2 or less. That's what we're doing here. Okay, we're doing 0, 1, or 2. So go back to binomial PDF. 2 at the 0, 1, or 2. Now if I enter, I get all those 3. Can't see it in the screen. But that's the probability of getting 0 successes, 1 success, or 2 successes. Okay. Now there's also a built-in function in your calculator. You've already seen it. It's called binomial CDF. Now what binomial CDF does is it gives you the probability of getting that many successes or less. That many successes or less. Okay, so we have 4 trials. Our probability is 0.85. If we want to get the probability of getting 2 or less, then we put in 2. So if we run that, notice we get the same thing that when we added up 0, 1, and 2. That's what the calculator does, the exact same thing that we do. It just takes less time to do it. Okay. So let's look at another one. Same setup, we're checking 4 pieces of lumber. What is the probability that less than 2 pieces of lumber are graded correctly? What is the probability that less than 2 pieces of lumber are graded correctly? So what does less than 2 mean? Less than 2 means either 1 or 0. 1 or 0. So you could do binomial PDF of 0, binomial PDF of 1, and add those together. That would do it. Or we could use binomial CDF. Now it's very easy to put in 2 for this, because you see less than 2, and you know binomial CDF gives you that or less. But we really need 1, because we want 1 or 0. So 4 trials, probability of success is 0.85. We get 1 or 0, and this gives us our answer. Okay? So now this says, what is the probability that more than 2 pieces of lumber are graded correctly? More than 2, let's be clear on that, that means 3 or 4. So I like to do this. First, let's list the number of successes that we could possibly have. 0, 1, 2, 3, 4 successes. Those are the possible ones. We want more than 2. You got to be careful. What does more than 2 mean? That means 3 and 4. Well, the calculator doesn't have a built-in function to do 3 plus 4. CDF always goes back to the left all the way to 0 successes. Okay, you could do binomial PDF of 3 and binomial PDF of 4 successes and add those together. But what we're going to do is we're going to take the probability of this and subtract it from 1. Because we know that the probability of getting 0, 1, 2, 3, or 4 successes, they all have to add up to 1, or 100%. So we're going to do binomial CDF of 2, and then subtract that from 1 to get 3 and 4. So we're going to do binomial CDF of 2 and subtract that from 1. So 1 minus second variable's option B, binomial CDF. And we're wanting 4 trials. Probability of success is still 0.85. Well, our X value is 2. We want 2 or less. And now I'm just kind of practicing with these words, because that's what a lot of the trouble for the binomial problems are. Is what does more than 2 mean? Is that the same thing as at least 2? And there's a difference there. We just got to make sure we understand that. So that's our answer there. So let's look at this one. This says, what is the probability of at least 3? And we got to think, what does at least 3 mean? Well, at least 3 means either 3 or 4. 3 or more, which in this case is 3 or 4. So again, the calculator doesn't go to the right. It doesn't have a built-in function to do 3 or 4. And actually, this is the same exact question that this asked. At least 3 is the same thing as more than 2. So we're going to get the exact same answer. You just have to take the probability of getting 0, 1, or 2, which is binomial CDF of 2, and then subtract that from 1 to get 3 or 4. So this one's the same exact answer. Just asking it in 2 different ways. More than 2, at least 3. They're asking the same thing. So now let's talk. This is our last example. We've got a little bit bigger scale here. Same setup, but we're grading 100 pieces of lumber. And we're trying to find what is the probability that more than 87 pieces of lumber are graded correctly. So first I want to go back to our formula. We can get the probability of getting exactly, let's see, more than 87. We got to think what that means. That means 88 all the way up to 100. Okay, so if we do our formula, we have 100 trials, and we choose 88 successes. That tells us how many ways can you get 88 successes out of 100. We have our probability of success. How many of those did we want to get correct? That would be 88. Okay. Times the probability of failure, which is 0.15. How many failures do we want? We want 100 minus 88. That would be 12. Now, this gives us the probability of getting exactly 88 successes. So what we would have to do, or we could do binomial PDF of 88 successes, and that would give us the same thing. So what the calculator is doing this formula, but it's doing it for 88, 89, 90, all the way up to 100, so it's doing it 12 or 13 times. Okay? So what we're going to take advantage of is we're going to do the exact same thing that we did last time. If we want 88 through 100, we get what we call the complement of that. That's the exact opposite of that. Because the complement of that has to add up to 1. Or the probabilities have to add up to 1. So I'm going to get 87, basically 0 through 87. And the calculator just does 0 successes, that does this formula. 1 success, this formula. All the way up to 87. And it adds it all together. And you can see that it doesn't take it very long to do it. A lot better computational skills than we have. So that's what we're going to do. We're going to do binomial CDF of 87 successes, and then subtract that from 1 to get 88 to 100, which is more than 87. So for our last problem, we have 1 minus I'm going to go to this prompt again. This time we have 100 trials. our probability of success is still 0.85. And the X value that we wanted was 87. This gives you, if you're doing CDF, the probability of getting 87 successes or less. And since we're subtracting that from 1, we're getting the probability of getting 88 successes or more. So that's our final probability, the probability of getting more than 87 successes or more than 87 of the pieces of lumber graded correctly.